Cool. Hey, thanks for joining everyone. So, working on some analysis of gender effects and alternative education. Um, Currently working to compute this fraud flag. So there's a few responses that I don't trust basically because they just do tens across the board on the skills. Um, so that's what this function is for. And yeah, what are we covering today? Hopefully get this flag boolean built out. Here's some exploratory analysis I've been doing. We already tested for difference of means, hireability metric, and um, like whether the person favors the idea of a programming career, like whether they'd be favorable to that, scale of 1 to 10, Likert type measure. And no significant difference in means, which I think is a cool result for guys and girls. However, we tested that with raw data, which is skewed, and then we implemented a deskewing function, tested it again, consistent results. But like before we just go down the path of like model optimization, like we're going to get to lasso, this we might think about like forward selection, backward selection, stepwise. I think we're going to do backward selection because I have some interactions, and I don't want like a genetic like calculating all the interactions. That's insane, and that's going to be overfit. So this is like my flat variables plus like analyst directed, expert directed special interactions for theoretical reasons. It's not ad hoc, there's theoretical reasons. And so that sort of top-down approach, obviously there's pros and cons, you know, human intuition is a pain in the butt. However, I have my theoretical explanations for everything that I pick, and that's like the substance of the whole paper, right? Anyone can pop out a machine learning model, then it's like, is it overfit? I don't know. Why did these, like, what's the theory? It's like, I don't know. It's like, it's just what the machine said. So that's not really optimal. Okay, Katie, what's up? Dagata, Kite, oh, some of y'all's names I can't pronounce. Richard, David, hey, thanks for joining y'all. So hopefully we'll get to the lasso and backward selection. Might do logit later. For now, we're just doing least squares. That's kind of a review of where we are to date. And so now I'm going to crack into trying to get this fraud detection function finished. Here I've started it, you can see. Basically, the way it works is if you give the same answer for all of your skill responses, then I'm throwing your response out. And I already looked at the CSV. I could do this by hand, but I feel like that's cheating. In the CSV, there's 3 of these. So it's not going to like really blow up my analysis, but want to get this done before I optimize stuff, right? Because if you change the sample, the optimizations will change. Richard, Javier, great to see you. Okay, so these are picked on an ad hoc basis, which I really hate. I just don't know how. Maybe I could do a regular expression and find the first 3 skill substrings. I guess that could be better. Let's see. But it's just the first 3 questions. So let's see if I can do that. If I can do that with a regular expression instead of doing that manually, that'd be better. So first 3. Let's just get the first. So I'll comment this, and this will be first skill column equals, I have the RE package. What does RE have? I could do find all, maybe that would be nifty. Find all, yeah, R, thanks Tab9. Got the Tab9 plugin, a little bit of AI-driven auto-completion is really nice. So they should all start with the skill underscore. So this is actually probably going to provide me a list, but let's see if it does what I want. So it's called first skill column, but it's probably going to give me like all the skills. Let's see. Missing 1 required positional argument string. Okay, so let me look up this method. Hold on. Does IntelliSense tell me? Okay, so the first is Any string find all. Second is any string find all. Yeah, let me find. The function definition here. Module provides regular expression matching operations. Cool, cool. Do you have an example? Okay, so here's an example, re search. Here's find all. Okay, so the second argument is like the string to search. Oh, here I was thinking it would find all the columns, but it just wants one. It just wants one string. So that's really not useful at all. I could just use find. Okay. So let's uncomment this. It's going to have to loop through every column. So let's, right here, I'm already using match, finding the skills. So let's do count done equals 0. We're going to start at 0 and we're going to build it up to 3. So sus value is going to start at 0. I just like to throw those in alphabetical order. So ABC, yeah. So allowance remaining, count done at 0. So here, if the column matches skill, then what we want to do is if count done is less than 4, because I want it to go up to 3 times, right? I want the average of the first 3. So if count done is less than 4, then sus skill value plus equals like the current value. So let's see if I can get current value. If it let's just see if I can get the current value. That alone would be cool. Doing a poll when you go, oh golly. Current value. So row dot should be the column index of row, I think. Okay, let's see what happens. Series has no attribute columns. Okay. This is the one right here. Maybe I could just do like so. How do I get all of the properties? Okay. Pandas series, like each property in pandas series. Just do values maybe. Expected string or byte-like object. What line number? 209, 105, 185? None of these are like, oh, 170? Yep, here. So, all right, let's even comment out the matching and just print what is column here. So this actually should probably be called value, but I'm trying to get the column names. Right, whoa, look at all this stuff. It's literally giving me the values. So let's kill that. Okay, it makes sense that values is the values. Can I have the column names though? Reference to the underlying data. Fine, fine, fine. Maybe attributes. Dictionary of global attributes of this data set. Okay, let's see about that. That did, yeah, so it flew through it like nothing. See, it refers to a column name here. Int is not iterable. Int is not iterable. Let's just print the row. Okay. So skill commute, skill commute, skill commute, right? So it's printing out it's printing out the column names. I'm just not able to access them for some reason. Let's see. What is this called? Maybe it's columns. So let's try row.columns. Series has no attribute columns. Okay. Name. Okay, so the name is really just the index within the data frame. Let's see. Oh, keys. Maybe it's keys. Return alias for index. So, was that beneficial? Item. Return the first n rows. Nope. Okay, so I think we can maybe try keys. We can also try item or items. Let's try this. Those all seem to work. Not really sure what the difference is, so I'll comment those. Let's do this. Uncomment here. So for column in row dot keys. So this would really be a key, not a column, but hopefully it's the same thing. Method object is not iterable. Method object is not iterable. Okay. Iterate over panda keys. For column in df, is that really all I needed to do? Okay, so I've been doing like trying to find the right attribute of row, but maybe I just do column of row. Okay. No, these are the values. These are not the column labels. See, this seems to be like the right thing to do, except that bro on the other said, like, never do this, basically. Maybe I'll just go ahead and do it. I should have linked right here why I didn't want to. How to iterate over rows in data frame. Right, so here's the top one, and the answer is like, don't. Right, so this is bro who says don't. But maybe you listen to the guy that has the accepted answer and more points. Row.columns. Thanks. I think, what do you think about this one right here? I think I can just use this answer. I was trying to vectorize it and or like use data frames.apply, and it's just not working basically. So right here, right, I want to create a new column. I don't know if that's going to work. So we can default it to true. Index, I don't care about the index. Row. Let's see. So I'm trying to avoid manually putting the column name here. So is it still a data frame here, or is it a pandas series? Let's see. Tuple has no attribute columns. Okay, so this is giving me the tuple. Label or, okay, so let's see, index. So if index is the label, that might be what I want. Yeah, there we go. So this says index. What, like this whole thing is the index? Interesting. Yeah, so index and row.index are not the same. Let's go back. I might do it. So that's giving me what I want. So I might end up using that. But I want to go back and see if I can get that within the df apply. So here I'm in df apply. Can I do column and row dot index? Is that a thing I can do? Okay, so that's actually what I want. I think I'm going to go this way instead of the iter. Instead of iterating through the tuples, I'm going to use apply because it's slightly higher recommendation. If we go back to bro who's like you shouldn't even be iterating over rows. If you look through his options, applies number 4, which he recommends above 5 and 6. So I don't know if this guy is awesome or not, but we're going to give it a shot. So for column and row, so this would be column and row dot index. Excuse me. Let's see if curve value is working now. Yeah, that's what I want. Chris, thanks for joining. So here's the skill and then skill value. Wow, somebody threw out some ones all over. That's pretty harsh. Is that even accurate? No, I don't think that's even accurate. Let's go back to the raw data. Is there anybody that legit like put ones everywhere? So yeah, this person put a load of ones. Okay, well look at that. This is the good reason for doing it with algorithms, right? Because this is fraud. This is a fraudulent record that I didn't even notice by hand. Okay. So the let's see. Here's the current value. If count done is less than 4, then subscale value plus equals curve value. Okay. Let's do if it's less than 3. If it's less than 3, so then elif count done is exactly 3. Then we're going to divide by 3 because we want the average. Yo, I think I might be dying. That's bad. And then else what? Else do nothing. Like, that's fine. So if it's less than 3 or equal to 3, and then here is the fraud candidate value. It's just curve value again. So if curve value is sus skill value, then reduce the allowance, and if it's like 2 strikes and you're out, basically. Save that, see if it runs. Unsupported operand, float, and string. Okay, so it's still thinking that, because I never converted all these skills to numbers, so it's thinking it's like string 1, string 5, etc. So let's do this. Curve value, we'll just int it. Just int it every time. What the heck? Y'all, I have tacos. I can go eat some tacos. It's gonna be great. Cannot convert float NaN to integer. Right. So this all assumes that there is a curve value. So if row column is none, can I do that? Bam. Is none, okay, in Python, does none equal none? I need to check that. Python check is none. if val is not none, right? I think I can do that. Is not none. Is none. Okay, so I actually did it the right way. If val is none, but I actually want to do if val is not none. Let's see if that works. I'm not sure because it's checking NaN. I'm not sure if that's going to be cool. Cannot convert float NaN to integer. Cannot convert float NaN to integer. Okay, so let's comment that. Let's slow that roll. Let's go ahead and cast it, and then if curval is not NaN, okay, that check is illegal. Python check is not NaN. Well, I guess I could like check if it's greater than 0. Hey, I appreciate the likes. That's awesome. Shiny Shart? Is that really your username? Wow. Okay. Life on TikTok, I guess. Hey, if you're watching on Twitch, I don't have my chat up. So sorry about that. It's asking me to log in, and that's like way too much work right now. I'm going to just do this. Okay, so if curve value is greater than -1, let's say that. It's never going to be 0. If it's greater than 0. And then we'll put a comment, greater than 0 is a quick non-check. Cannot float non to integer. What? What are you talking about? Every time I read non, it makes me think of like non-bread. Cannot float non to integer. Okay, is null. That's nice. Okay, so I could do to numeric. Okay, so the issue that I'm facing is that not everyone has skills filled out. So this is going to limit my total data set. I don't want to do that, so I'm going to move that logic to the same place where I'm deskewing. So get deskewed data. So here, even here, I feel like it's kind of potentially savage, right? So let's grab this. No, that's fine. It can be part of my deskew algorithm. Okay, all right, so we'll include it there. Just Kelsium. Sorry if I'm saying that wrong. Hey, thanks for joining. Okay, so we're basically going to drop them if they don't have skill values. But I can't put a regular expression there. Is there anybody who has like some of the skill values in the raw data? That might not even be a thing. It might be like all or nothing. Here is the wrangled. Okay, so for sure, these are like a bunch of missing skill values, basically. what's the first one? Okay, so this is the first one. Let's turn it red to make it easier to see. Okay, so is there anybody that has this column filled out, but then later they decide to stop filling it out? I'm pretty much just seeing white lines or filled lines. I don't really see any mix and match type situations. I can sort this. Let's sort it. Data, sort, skill. Bam. Right? Okay, so what did I just do? I just sorted on people that have filled out this first column, and we can go all the way down and like here are people that didn't fill out that column. But all of these people did fill out the column. So I can control arrow right or command if you're on Mac. And what I see is at least for that first row, they did fill it out. Okay, and now I can control down, or if you're on Mac, command down, and go to the bottom. And what I'm seeing is it appears to be like a square grid. If I was like a little more thorough, I would like write a little program that actually checks if that matrix is filled, but it looks filled, right? So I'm going to don't save. And what I'm going to do here, and I feel a little better because that was like a single page of the survey. There was like one page that captured all the skill effects. So I feel like you either submitted it or you didn't at the page level. So I'm going to put a comment that if you don't have the first skill, you don't have if you don't have the first skill, basically like skills are all or nothing. If you don't have the first skill, treat as if you have none. Okay, I think that makes it clear. So what is the skill? The skill is skill underscore, I think it's like level of physical attractiveness, I think. This one. This is the first skill question. So go in here, close this out. And I need to make that numeric. This is like such a pain in the ass. What I'd like to do here is make them numeric. So can I convert it to an integer right here? I might be able to do that. So this would be a pandas series at this point. Pandas series convert data type. Cool. So let's try try that instead. And we'll comment this for now. So now I'm dealing with deskewed data. I'm okay with that, right? Yeah, so let's go to our second file where we're actually dealing with deskewed data. So we'll invoke it through here, deskewed data. I'll just put it at the bottom. So here we want to, what, print deskewed data? No. We just want to get it. We just want to get it. So cancel this. I'll just make a temporary change in my current file. So get deskewed data. Currently we're using get data down at the bottom. And then I'll just stop writing to the CSV. Okay. Data frame has no attribute is serious. That's right. So where was it being referenced? Here. Yep. Yeah, this is Python. Thanks for asking. What are you making? I'm doing a data analysis. So we're trying to find gender effects and like why aren't there enough girls in tech, basically. As well as non-gender. Although I only have 2 respondents that said that they were other genders, so I can't really do any analysis there. But yeah, basically, in computer science programs, enrollment is like 20% female. In coding boot camps, enrollment is like 40% female. So the question is, first question is like, why? Why does that difference exist? So testing a bunch of theories there. And the second question is, how can we get employers to use boot camps more and CS programs less? So those are like the 2 big questions. You're in a coding boot camp? Lit. Congrats. I hope it goes well. Follow me. Let me know how it goes. Most of the time I'm teaching people how to code. I'm actually rarely doing data analysis, but this is one of those rare times where I'm doing it. Yeah, Lambda School's cool. You got the income sharing agreement? I'd love to know your thoughts there because a couple years ago they were like the best school, and then I guess last year they got in a bunch of trouble, and so now it's like a question: are they still awesome or not? So what do you think? This is JT Royalties. What do you think? Are you enjoying it so far over there? Learning a lot. That's great news. Okay, so this is float has no attribute. Float has no attribute as type. So I feel like these are like 2 different steps, right? One is that I want to convert, yeah, let's do 2 different steps. I want to do pandas to numeric, okay? And I want that to apply to all of my skill fields. I guess the best thing to do is just come up with a string list. So let's say this is called column names to numerize. Column names to numerize. And that is this bad boy right now. I don't know why I didn't think of this sooner. This is like basic programming. This is not even like a complex data analysis subject. This is just like basic programming. So we want to numerize all these, right? And then I want to drop this piece and not enter them manually. And frankly, I don't want to do that for favor either. So df.column. So column names to numerize equals df.columns dot filter. Can I say filter in Python? Doing Python in 2 weeks. I'm a self-taught programmer. Hey, me too. Congrats. Go team. Yeah, I taught myself multiple languages, including Python. Okay, so Python filter string array. I guess in Python you'd call it a list, wouldn't you? Yeah. Oh, I can do a comprehension. That's going to be super clean. Yep. Okay, so K for K in list if A, B, and K. Yep. Here's LST. Okay, so here we go. K for K in list. Let's do S for S in df.columns. If skill in S. Okay, so this should give me all the skills. I have a special hatred against Python syntax. Hey, me too. I don't teach people that they should be learning Python. If you go look on my page, it says CEO of Learn React, not Python. I think you should only learn Python if you want to do data analysis specifically. And that's what I'm doing right now. But in general, I don't recommend it. If you just want to be a programmer, or especially if you want to be a web developer, I don't recommend Python. Okay, so this is, I'll call this favorability columns. Favorability columns, and we'll do the same thing, but grab if it's prefixed with favor. 1, 2, 3, bam, crush those. So here's the favorability columns. And what I want to do is like concatenate. So Python concatenate string list. I can just use concatenate method, I think. Oh, concatenate operator, that's wild. See, look at this, that's pretty cool. Some things in the Python syntax are cool. Concatenating lists like that is really cool. Okay. So here we will call this skill columns. So skill columns, favorability columns, and then this is other columns to numerize. Other columns to numerize. I feel like so autistic sometimes because I want it to always be alphabetical. Otherwise, it's like pissing me off. And I'm like, it's not pissing me off, but it really is. Okay, so here's favorability columns, other columns to numerize, and skill columns. And then columns to numerize is the concatenation of these three. So 1, 2, 3. I appreciate all the likes. Be Cooler 79 joined. Whoa. Looks like the stream just got cooler, y'all. Okay, so these are the columns to numerize, and then we apply numeric to them. Makes sense to me. Does that make sense to y'all? This code block makes sense to me. So now that we've done this, I can't believe you have done this. So I shouldn't have to as type int that bad boy anymore. Boom. So it should just be a number, right? Right. All right, well, I'm not seeing errors. It's printing a shitload of stuff. It didn't seem to be erroring, so that's good. So what is it printing? It looks like it's printing out my column names. Is that what I want? Like, not really. Why is it printing out my column names? Print column. Oh, I mean, that makes sense. That makes sense why it's doing it. Okay. So, cool. So we get the average of the first three, true sus skill value. compute fraud flag is here. So let's get the dskewed data and see if I can, here, I'll make a new file. Wrangled dskewed. Why not? Let's just make them both. So this would be the dskewed, or this would be the, we'd want to calculate skewed data first because dskewed is a function of skewed. I'll put it to do. F skewed data, am I right? Oh, wow, analyst jokes. F skewed data, and you get D skewed data. Come on. I hope someone appreciated that. Okay, so we just have ordinary get data. So this would be data, or it's called skewed data, just to be clear. So we get data, here's the skewed data. That goes to our wrangle file. And then there's the D skewed data. And it's going to a new file. Let's hit it. Just type HTML and hit tab, bro. Wow, that's fire. See ya, JT Royalties. Gotta go. Lecture break is up. Geico Insurance. Whoa! Just got followed by Geico Insurance. I'm famous now. All right, so here's our dskewed data file. Boom, opens up. Looks pretty, doesn't it? And is serious column completed? This is what I was checking. Is serious column completed? Boom. So good news is that we produced the file without error. Bad news is that these values are wrong. These values are wrong. Okay, why is the data bad? Why is your data bad, John? Why are you bad? Why is your data bad? And how have you gotten this far in life when your data is so bad? Please explain. Okay. So what we did is we tried to calculate the is serious flag, but it's just always true, isn't it? So I don't think that the algorithm is not implemented properly. Vegan living, wow. What's up, vegan living? Column and index, yeah. Matching skill, this is great, great. We got the current value. Okay, wow. If the current value is greater than 0, right? Everything so far is so good. So I think the problem is we just keep adding here, which makes sense because I never increment the son of a gun, son of a dookie, son of a dookie. So I gotta increment that bad boy. Wow, is that a one-line fix? I'm gonna be so hypey McHyperson if that is a one-line fix. Whoa, how fast did that just execute? That was abnormal. Your face is abnormal. In a good way, got him. Look, false 10, look. So it detected that this is sus, right? Because it's all 10s. You sus, dog. False 7. Okay, no, that didn't work. That is wild, though. That is wild. The average of that happens to be 7? That's pretty improbable, right? And the average of this is 6. Okay, so basically my algorithm is busted, and this is a bad idea. Poo. Oh, and it's true on these guys. How do I feel about that? I feel like if it's 0, it needs to be considered is serious false. And the term serious, I don't know about that term. It's more like has valid skill response. This is like a third there's like 3 possible states. Crypto Bua joined. What's up, Crypto Bua? How you do? Okay, so yeah, I think it's proper. If you just didn't fill these out, that doesn't make you fraud. Is serious is false. Yeah, this part is broken now. Okay, so if the current value is the sus value, um, okay, yeah, I did that wrong. So this is basically saying if you run into it twice, you're sus, which is not what I want. I want if you run into it all the times except twice. So if current value is not sus skill value. Oh, sorry, dang, I had my file still open. I can't read and write. I know. Don't save. I got it. Bam. Okay, so now the divide by 3 is not working. Why is the divide by 3 not working? Now everyone is sus. That's so bad. Why is it not dividing by 3? That's kind of wild, isn't it? So if the current value is greater than 0, and if count done is less than 3, so we start at 0, bump it to 1, bump it to 2, bump it to 3, and now we're at 3. Let's comment that for a second, because that should have nothing to do with it. So I'm going to write this differently. It could just be a syntax issue. I want it to be itself divided by 3. Okay. Whoa, now it just like divided by 3 a bajillion times, and that's not what I want. Oh, so I need to increment it like 1 further, basically, so that you don't keep doing that. Cool. Now we got the third divisor. Okay. Is there a way to like check is a whole number? Because I can just quickly exit if that's the case. Okay, so what the heck? Now it's back up to 30. Why are you back up to 30? What language are you using? This is Python. Hector Fernandez, thanks for chiming in. And everyone is false. So I'm returning too early. That's what's happening here. So if I comment this, it will compute the divided by 3 properly. So I need to do if current value is greater than 0. So this needs to be within an elif, basically. Elif count done is greater than 3. That's the only time that I want y'all to do this. If the count is greater than 3. Then check if it's the sus skill value. Permission denied. Okay, got to close the file, maybe. Python for data analysis all the way. At least at the moment. We'll see if that changes in the future. Okay, so this is good, except it's inverted. My truth should be false. That's fine. So this, so instead of calling it is serious, let me see. So we'll say is non-serious. I don't like negated naming like that. So here, so this person is has no skill columns, basically. They have no skill columns. That's never going to occur, but I guess it's safe to just go ahead and return there just to be safe. But they should always have the column. I don't know how programming really. I'm an electronics engineer. I want to learn program on Python or PHP. Have fun. Seems like you're not in the USA. I guess the ideal programming language for your job market varies by country. I recommend that people learn React, JavaScript and React, if you want to become a programmer and land a job as quickly as possible. I only recommend Python if you specifically want to go into data engineering or data science. And I basically never recommend PHP. So if you're asking me to pick between Python and PHP, I will pick Python. But I would say if you're going to learn Python, look for a data engineering role. I don't know. If you learn a programming language, then once you've learned it, it's cool. You can do whoever will give you the job. But I would only really advise Python if you want to do data engineering, basically. Okay, so, and thank you for the likes. I appreciate that. Scats89, what's up? Thanks for joining. Yeah, JS is pretty good. And if you get discouraged with JavaScript, the one thing that I would say is hang in there, because once you learn JavaScript, it's a prerequisite to learning TypeScript. And TypeScript is like definitely better than either JavaScript or Python. It's like way better than either one. And that's not like my own opinion. Like there's data for this here. Stack Overflow Developer Survey. So check this out. Loved language. So here are the loved and dreaded languages. So Rust, amazing. Clojure, and TypeScript is the third most loved. But you need to learn JavaScript before you can learn TypeScript. And then JavaScript is down here, kind of in the middle. Most people still love it, 61%, so more love it than hate it. But what I'm saying is it wouldn't surprise me if you go, oh man, I'm trying JavaScript, I actually like Python more. That wouldn't surprise me. I would say hang in there though, because you're going to realize TypeScript is like way, way better. And it's worth hanging in there. And Rust is awesome too. But you can't use Rust for much. It's like pretty much server-side only and like specialty use cases. JavaScript is great because you can use it for so many use cases. React, you can do mobile apps, you can do websites, you can do desktop apps, you can go full stack. If you want to be a full stack developer, you have to know JavaScript. It's the only truly full stack language. Okay, as we were. So So this is true that it's good in that case. And this is true that it's good in that case, but this is false. It's not good in that case. I don't think that my false statement here is accurate. So for each column in row.index, yeah, I would need to check the, if current value is greater than 0, and if it's not greater than 0, then we go over here. Count done is greater than 3. Here is where we should check if allowance remaining is greater than 0. Okay, I got it. So if sus skill value is 0, then we can return true, and then else we're going to return false. Okay, let's see if that fixes the problem. Okay, so false, correct, 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 correct. Where's my ones at? One of these. And these people are the sus with all the 10s. You see that? And let's see. One of the guys had a bunch of ones. 1, 1, 1, 1, 1. So this person has a bunch of 10s. Let's see. Sort by skill. Okay, it looks like that person was dropped for other reasons, which is fine. So here are the 10s. Oh, this person is true. Okay, so these 3 are bad, and it looks like the machine is correct. So those are the only 3 in the wrangled data set. Okay, yeah, there was like another bad one in the raw data. Here, I'll go to the raw data. But it looks like that person didn't survive the deskewing anyway. So here, oh, you can't really read this, but they put, because it's not numerized, very little. Let's see. They put like 1s across the board. Yeah, very little. This person right here. So this is a non-serious response. They just put very little every time. Close that. Okay. Cool. So this works. So compute fraud flag. So is serious is being computed. Now, here's the thing. Compute fraud flag. What I want to do is, can I do this? I don't know if I can do this. Too many values to unpack. Okay. See how I'm returning? I'm actually returning 2 different things. True and sus skill value. I was trying to unpack them. That's fine. I'll just leave it internal. I don't really need to know that sus skill value. Cool, so this seems to work. So we can get rid of all of this goofiness. And I might even be able to put this into the general wrangler instead of the deskewing wrangler. Let's see. Toby, thanks for joining. Cool, so what I want to do here is only maintain them if they are serious, right? Yeah. Cool, no errors that time, loving that. So in this case, the wrangled data should have the flag, I just don't filter it out. So let's go see if that worked. Is serious, there's the false flag. And here is that one I was telling you about. There's numerized all the ones and we caught it, that's great. But that person is filtered out by the deskewing algorithm anyway. Cool, so I like this a lot. I like this a lot. And it makes sense that whenever we deskew, we're taking out the non-serious at the same time. That makes sense to me. So let's go to deskewed. Now it's just true across the board, yeah? Good. And how many samples are we working with? Okay. This is really great news. So I'm going to commit this towards git add. "22 John Marr, what's going on?" And that's like a much more concise to numeric method, right? So the feature here is that compute fraud flag is working. There's like 3 features in this commit. It's kind of a big commit. So standard commit message. So we'll put that as the feature and output deskewed CSV and concise numerization. Great. Cool, and we're almost done. Now that it's like cleaning the data is like most of the fight, right? Then the analysis becomes pretty easy. So now that we've done that, I want to reanalyze our deskewed data. So we have skewed and we have deskewed. And then we have left of skew. Which, yeah. Left of skew, is the name still accurate? I think so. So this is our analysis 2 file. Gonna look at the skewed, the deskewed data test to make sure it's still deskewed. There is like a lot of printing out here that I don't need. Why is it running regression? Okay, I guess I do have the regression in there. Let's comment all this stuff because I don't really care about it right now. Hot sauce committee, what's up, what's up? Okay, so deskewed data is still skewed. No, it's not. And skewed data is skewed, yeah. With that, that's a tiny p-value. Deskewed data is still skewed. No, it's not. So skewed data skew test. And then we have deskewed data skewed test. Okay, and what I want to do here is say, can I back up my skewing algorithm and get a couple more samples in there now? Now that we've cleaned out those kind of like gross non-serious respondents, right? So previously we were thresholding at 5. Let's break it over to 4. And what is my p-value? I want to see a p-value higher than 0.2, and I'll be happy. No, yeah, 0.08. Okay, it's still skewed, so we'll keep it at 5. Boo. All right. Cool. So that's definitely non-skewed. So we're good. Skewed is good. De-skewed is good. Now, I don't even care about this left of skew data. I mean, yeah, there aren't enough samples in it, right? Left of skew, failed skew test due to insufficient sample size. Left of skew fails skew test due to insufficient sample size, which is kind of a good thing because it's like I'm not dropping that many samples. All right, now let's reanalyze. Now that we have the new de-skewed, let's reanalyze our male-female basic mean difference test. Higher ability mean diff test by gender. So the p-value is like over 0.5, so it's like not even close. Cool. And let's check the in favor programming career. What, did I never print that? Okay, I guess I print that at the bottom. You a scripter? What are you scripting? I am a programmer, and right now I am doing some Python data analysis. So this is for an academic paper that will be, I'll be presenting at the Southern Economic Association conference next month in Houston, Texas. And the question is like, hey, like, why are there so few girls in tech? You know? So in computer science programs, enrollment is about 20% female, or you could say about 80% male. There is, you know, non-female, non-male, non-binary, other gender identification, which is really interesting, but it's like a really small percent of the sample. So I only had 2 people that gave that gender identification for me. So it's more or less male versus female, but you know, maybe the non-male term is better than strictly just saying female. So yeah, so why are CS students 80% male and college and coding bootcamp students are only about 60% male? It's a big difference. It's a big difference if we care about gender diversity in tech. So analyzing the reasons there. Okay, so here's the difference. So we just showed the difference in means and hireability is insignificant. Just to make this clear, what does this mean? What this means is, so if we're like, hey, why are there so few women in CS programs, but there's so many women in coding boot camps? One of the explanations would be women just like coding boot camps more than guys do. It's like a brute fact explanation, if that makes sense. You could say that there's something about the culture of a CS program that is unattractive, or there's something about the culture of a boot camp that is attractive, disproportionate to gender. But we just have provided evidence that none of those are true. We just provided evidence that like none of those explanations are valid. So a second one is well, maybe it's not about the coding boot camps versus the college programs. Maybe it's the career level. Like the whole idea of a programming career is unattractive by gender. So that's what we're about to test now. And it may surprise you or may not, that my hypothesis is that this will be insignificant, is my hypothesis. Okay. Favor programming career. Here is D-skewed female versus D-skewed male. All right, let's check. Yeah, so the p-value is 0.7, which just means there's absolutely no statistical significance. It's like, this is evidence against the theory. It's not even just like we don't have evidence for. It's like we have good evidence against with this. Sample size is 99, which is like, so I surveyed, I got like 114, I think, responses. So this means like I've had to cut 15 of them to get to this point, but I'm okay with that. Okay, below analysis using D-skewed data. Cool, so let's do our basic regression exploration again. So industry effects alone is N1. So I expect between 10 and 40 R squared, 0.1 and 0.4. Yeah, so it's about 0.2. So yeah, like the industry you're in tells us something useful. It does. Got some significant industries and then some that don't matter. Like military doesn't tell us much. Finance doesn't tell us much. Education doesn't tell us much. But, oh, what is this one? Health really doesn't tell us much. But energy tells us a lot. Real estate tells us a lot. Okay, and then some of these are sort of like middling. So IT is like middling, law and manufacturing as well. Cool. So let's go to M2. M2 is the three-way interaction. And so, oh, let me update the... So this is N105. N105. I want that AR2 up front because I want it alphabetical because whatever. I just want it alphabetical. Can you love me, please? Thank you. All right, so industry alone, the AR2 was like 099 or it's like 10. I'm just going to 2 decimals. All right, and so here's 19, boom, and 105. Cool, so now let's go to M2. And this is the three-way interaction. And basically the hypothesis is that the three-way interaction is much better than industry. That's the argument here. And it is. Look, the R squared is, what would that be? 0.19 to 0.24. It's like a third. It's like 30% better, roughly. But the adjusted R squared is like 80% better. Something here doesn't matter. Oh, the favor risk-seeking interaction doesn't matter. That's interesting. All right, so let's jot down these numbers. We did have to give up some observations for this. So there's like 6 people where we have the industry data, but we don't have all of these metrics, right? So that's why, because there's like partial responses in my survey, basically. Cool. So the R squared is 24. And the AR2 is 18. And what is my AIC? Oh, yeah. I need to start including AIC, BIC. I don't really care about BIC, sorry. Let's do AIC. AIC is 306. I need to go back and get the other one. All right, 243184. 241899 Let's go back to M1. Tall guy, what's up, tall guy? Thanks for joining. Okay, so AIC is 339, which makes sense. So lower is better. So based on like R squared alone, I was already preferring, like y'all could tell, I was preferring this M2 already. And the AIC is just yet another data point consistent with that. So now the question is, we have these two, I guess let's say moderately good explanations. The question is, are they independent from one another, so you can kind of add them up, or are they the same explanation? Which is a tricky thought, but it's possible. So the idea here would be, whether you favor a programming career already determines the industry you pick. Like, if you favor a programming career, you're going to go to information technology. If you don't, you're going to go to some other industry. Whether you're risk-seeking already determines what industry you pick. If you are risk-seeking, you're going to go into the military. And like, if you're not, you're going to have a lower propensity for that. And same with gender, that if there's these massive industrial gender effects, there's an endogeneity between M1 and M2. So M3 is, let's test them independently, and M4 gets wild. It's where we do a four-way interaction. And that'll be the last thing we do this stream. So I'm speculating that M4, the four-way interaction, is going to have too many insignificant variables, and the AIC is going to be lower. I'm speculating M3 is going to be kick-ass. And so basically, I'm hypothesizing, right? I'm saying this before I run the regressions. I'm hypothesizing M3 is going to be preferred out of this exploratory set. Well, let's go see. So here's the three-way interaction, and here is independent entry of industry, right? So this is M3. R squared 383, adjusted R squared 245. So the adjusted R squared barely ticked up. Look at that. And it's still 99. All right, here we go. So let's write this in. And it's still 99. The R squared is 38. Oh, I'm sorry. Okay, I was getting numbers mixed up in my head. So, and 245 does round to 25. So the R squared went up by about almost 50%. So that's way better. I was comparing the adjusted R squared to the old unadjusted R squared, which is apples and oranges. That's not fair. So we have better total explanatory power by about, what, 50%? Yeah. And then we have better adjusted explanatory power by about 50%. So it seems that these two factors, industry and the three-way interaction of gender favorability and risk-seeking, seems like those two vectors are about 50% orthogonal, roughly. So they're like halfway endogenous, which is another way of saying there is benefit to including them both. Now look at this. The AIC went up to 308. So you would think that it's worse. But if we're looking at all of these, what we know is that this model has way better explanatory power. And so then we have to ask the question, well, if the explanatory power is way better, why is the AIC worse? And I think the answer is the informatic concentration of the factors. I know we're getting into like statistics 606 over here, like way above basics. But basically, the model as a whole is better, but there's going to be a few insignificant factors in here, like that need to be dropped, basically. So let's look at that. And we can see, yeah, like this one is unacceptably high. You shouldn't have a 0.9 p-value. Like, drop that factor. It's really harming the model. It's harming the model. And even these other ones that are over 0.5, like this, 0.6, 0.6, these all seem like too high. But this is exploratory. All of those optimizations will be done in a systematic way by a lasso or by a backward selection algorithm, and that's in part 3. All we're doing here is we're really defining the upper limit of our explanatory power, which is really going to be closer to the R squared than the AR squared. And more specifically, we're testing the endogeneity of these two explanatory pathways, more so than really optimizing a model. Okay, so last but not least, here is the wild one. Boom. I don't even know if I have the samples to compute this M4, because you interact with industry. There's a lot of interactions, right? But let's see. Let's do it. Look at all the variables. Cool. So we got all the way up to R squared of 0.639, which is like definitely overfit because the AR2 didn't even budge much, right? And the AIC is increased, but it increased a lot less than I expected, which is interesting. So that means there probably are some meaningful interactions in that bucket. Okay. Sample is 99, AIC is 319, R squared is 64, AR2 is 26. Really? AR squared is 26. So the AR squared actually went up. So the four-way interaction is meaningful sometimes. And meaningful not even sometimes, it's like it's meaningful on average in the average case. However, many of these are insignificant, basically. Like, look, there's a 975 that we should be dropping. Boop. There's a bunch of these that we should be dropping, and that's collinear. Non. Got a non in there. Got a couple nons in there. So, so this model is definitely overfit. This model is def overfit, but four-way interaction is meaningful in the average case. Could be a good backward selection or lasso starting point. I think that's what we're going to do. I think I'm surprised, to be honest with you. I was expecting a decrease in the AR2. So it's great that like things can still, surprise you. You deal with the data so much and it still surprises you. I was expecting that the spurious interactions would be so frequent that the average case would be diluted in explanatory power, bringing the AR2 down. That turns out not to be the case. So what that means is that a bunch of these side interactions are worth keeping. Now, I'm not going to go through by hand. I'm going to throw that through a process, but I think we'll do that next time. Really promising. Thanks for tuning in. See you later.